Evaluating limits graphically. So I have two examples here. This one, which is more of a smooth curve that has a hole, and this one, which is more built like a piecewise function. I want to evaluate, these curves at particular points. So the very first one, I'm asking you to evaluate the function at 3. And the second question is I'm asking you to evaluate the function's limit at 3. Now, f of 3 is the point on the graph that, is equal to 3. And we can see at x is equal to 3, this point is part of the function, which is 2. So if I evaluate the function at 3, I'm going to get 2 back. Because remember, the function, since this is a whole, it's not evaluated at that particular y value. So its evaluation is equal to 2. But when we ask for a limit, we don't ask for the value at 3. We're actually asking for the values when they get close to 3. So I can see from the left-hand side and from the right-hand side, we can see that the y values are getting close to 5. So the limit is 5. So be careful of the difference between the evaluation of the function and the limit of the function. So here I want to determine the limits of f of x at 1, 2, and 3. So as x approaches 1, we can see from this direction and also from this direction that those y values are getting close to y is equal to 1. So this will be equal to 1. As x equals 2, we can see from the left-hand side, as I approach 2 from this side, and from this side, we can see that that is going to be 2. So this will be equal to y is equal to 2. Notice the function is not defined at 1. So if I asked you what is f of 1, we would say it's undefined because there's a hole there. This function is, however, defined at x equals 2. So if you plug in x equals 2, you're going to get y equals 2 back. But again, it doesn't matter if the function is defined at 2. We only are asking for the values that get really, really close to x is equal to 2. Now, if I ask for the limit as x approaches 3, we can see from the left-hand side that its y value is getting really, really close to 2. And then from the right-hand side, we can see that its y value is getting really, really close to 3. So we'd say this limit does not exist, because for a limit to exist, they have to be the same y value from both directions. Which really brings us into, one-sided limits graphically. So this is going to be our f of x function, which is the blue function. And I want to know what is the limit as, so say A, what is the limit as x approaches 2 from the negative direction of f of x? And then B, what is the limit as x approaches 2 from the positive side of f of x? Negative side means from this negative direction, positive side being from this positive direction. So as I approach 2 from the negative side, we can see that right on the train, we can see that the y values are getting close to 4. So as I'm approaching from the negative side, its y values are getting close to 4. And if I approach this from the positive side, so from this direction, we can see that its y values are getting close to 1. Now, if I asked you what's the limit as x approaches 2 of f of x, if I didn't have these one-sided limits, the limit doesn't exist, because for the limit to exist, the left-hand limit and the right-hand limit have to be the same. So these are graphs that have a horizontal asymptote. This horizontal asymptote is at y is equal to 0. So if I ask you what is the limit as x approaches negative infinity of this function f of x, we can see is we're driving on the curve as we go to negative infinity. Negative infinity being out here. As I'm on this curve, we can see that it's getting closer and closer to y is equal to 0. Now, as I go to positive infinity, it's shooting off to infinity. Now, for this one, I can ask you what is the limit as x approaches, negative infinity of f of x, and I can also ask you the limit as x approaches positive infinity of f of x. So if I'm approaching negative infinity over here, this would be negative infinity, we can see that the y values are getting close to 2. So this is going to be equal to 2. And similar here, as I'm going to positive infinity, we can see that these y values also are going to 2. And that's how we can determine if things have horizontal asymptotes, is we're asking what's the limits as we go to plus or minus infinity. Do they equal a constant? As opposed to this one, if I ask what's the limit as x goes to infinity, this is going to shoot off into infinity, so it doesn't have that horizontal asymptote. Now this has a vertical asymptote. So what we're going to ask is we're going to ask one-sided limits as I approach x is equal to 3. So I could ask A, what is the limit as x approaches 3 from the negative side of this function? And I could also ask, what is the limit as x approaches 3 from the positive side of f of x? Again, negative direction, positive direction. So as I'm approaching 3 from the negative direction, so from the left, you can see that this thing is shooting off into, well, it's going to go down forever. It's shooting off into negative infinity. So this is going to be equal to negative infinity. But if I'm approaching 3 from the positive side, so from the right-hand side, this is shooting off into positive infinity. So this will be equal to positive infinity. So horizontal asymptotes, the x values are shooting to infinity and the y values are becoming constants, as opposed to the vertical asymptotes, you're approaching a constant in your x, and then the y values are going off into infinity. So determine the graph of a function with properties So what I've given is I've given horizontal and vertical asymptotes. these being as opposed to vertical asymptotes, where the x's are going to a constant from both directions and the y values are going to become infinity. So I know that this represents a horizontal asymptote of y is equal to 2. And this one represents a vertical asymptote of x is equal to negative 1. So now I just have to hold true to the properties to be able to graph this. So I'm going to start out with the vertical asymptotes. So as I'm going to negative 1 from the left-hand side, we know that we're shooting off into infinity. So as I'm approaching negative 1 from this side, I'm going off into infinity. Now I know as I go to negative infinity, this has to approach 2, so it could look like that. And then similar, as I'm approaching negative 1 from the positive side, this is going to go to negative infinity, so we'll go down here. And as I approach infinity, x is equal to infinity, I can see that the y values are approaching 2. So here's a possible graph for those particular properties.